start the read for Section 3 of Chapter 12, Mass Movements and Erosion. Typically, weathered rock materials do not stay in place. Wherever the ground slopes, gravity causes soil and rock fragments to fall, slide, or move at slow speeds to lower levels. Rain or wind may remove sand and dust from the side of a hill. A river transports weathered material downstream. Mass movement refers to the downward transportation of weathered materials by gravity. Erosion is the removal and transport of materials by natural agents such as wind and running water. Soil partially protects the bedrock beneath it from weathering. By removing the soil and loose rock materials, mass movements continually expose fresh bedrock to weathering, thus speeding up weathering processes. You can see the results of mass movement at the base of many steep slopes. Geologists use the term talus to refer to rock fragments that have been weathered from a cliff and pulled down by gravity. Talus piles rest against the cliff at angles as great as nearly 40 degrees. Landslide is a term commonly used for the movement of a mass of bedrock or loose soil and rock down a slope of a hill, mountain, or cliff. Landslides are most likely to occur on steep slopes. Roads or houses built on or into the sides of steep slopes are at risk of being damaged by a landslide. The risk is even greater in regions near volcanoes and in earthquake-prone regions where eruptions and seismic tremors can trigger landslides. People can avoid injury from landslides by knowing when the danger is greatest. Landslides tend to occur after heavy rains or during the spring, when large amounts of snow are melting. Rain and water from melted snow add weight to soil, making it easier for gravity to pull soil down a slope. Rain and snowmelt also may create a layer of water beneath the soil and the underlying bedrock. This layer may make it easier for gravity to pull soil down a slope. Geologists use various terms: creep, slump, earth flow, and mud flow, for example, to describe different types of landslides. Creep. Creep is a slow, imperceptible movement of soil down a slope. Its effects are noticeable, however, because creep causes fence posts, poles, and other objects fixed in the soil to lean downhill. The presence of water in the soil contributes to creep. Slump. Sometimes blocks of land tilt and move downhill along a surface that curves into the slope. This type of movement is called slump. Slump tends to occur because the slope has become too steep for the bottom of the slope to support the soil at the top of the slope. For example, if the rock and soil at the bottom of a slope become worn away, the top of the slope becomes unstable and slumps downward. Earth flows. During an earth flow, a mass of weathered material that has been saturated with water flows downhill. The downhill movement is slower and less fluid than a mud flow. Factors affecting the velocity of an earth flow include the amount of water present, the composition of the soil, and the steepness of the slope. Some earth flows take place relatively quickly, perhaps over a period of days. Other earth flows may last for a period of years. Geologists have found evidence that part of the Slumgullian earth flow in Colorado has been moving for about 300 years. The active section of this massive earth flow is about 3.59 kilometers. Mud flows. A mud flow is a rapid movement of water that contains large amounts of suspended clay and silt. Mud flows contain more water than earth flows and have been known to travel at up to 100 kilometers per hour down steep mountains. Mud flows are capable of moving rocks, boulders, trees, and houses. They tend to occur in drier regions that experience infrequent but heavy rainfall. Although mud flows occur most often on steep, barren slopes that erode easily, they can also occur on gentle slopes that are prone to erosion. Lahars, which you learned about in Chapter 9, are mud flows that accompany volcanic eruptions. Heat from erupted materials melts snow and ice on top of a volcano. Water cascades down the slopes of the volcano, carrying mud along with it. The photograph below shows a lahar that followed the 1985 eruption of Nevado del Ruiz, a volcano in Colombia. The devastating lahars from this eruption traveled about 100 kilometers. In the town of Amadeo alone, over 20,000 people were killed. Erosion and landforms. Rivers and streams, glaciers, wind, and ocean waves and currents are all agents of erosion. By removing and transporting earth materials, these agents play as important a part in shaping a landscape as the forces associated with plate tectonics. Climate and the composition of rock are two other important factors that affect erosion in a given region. The topography of a region depends on the balance at any given time between forces that uplift the land and agents of erosion that wear down the land. Even as rocks are uplifted, weathering and erosion are acting on the rocks. Sometimes uplift is more apparent than erosion. The Himalayas are being uplifted more quickly than they are being eroded. As a result, these mountains are growing higher over time. Their topography is rugged and sharp. In contrast, erosion is now the dominant process in the Appalachians. The effects of erosion are apparent in these mountains. Their topography is more smooth and rounded than the topography of the Himalayas. The effect of erosion on topography is also influenced by climate. In regions with humid climates, water is the primary agent of erosion. Because water is such an effective agent of erosion, humid regions tend to have more rounded topography. The topography in regions with dry climates tends to be sharp and jagged. The composition of rock also affects rates of erosion. Some types of rock are more resistant to erosion than other types of rock. For example, the rock structure in the photograph at the left is all that remains of an extinct volcano. The outer layers of the volcano have been eroded away, leaving behind a more resistant plug of igneous rock called the volcanic neck. And I apologize, in this edition there is no picture. The volcanic neck is made of hardened magma, the molten magma that originally arose upward in a volcano when it was active. In later chapters of this unit, you will read about how weathering and erosion are involved in the shaping of other landforms. At this time, you need to use the back of the note-taking guide to answer questions 1 through 4 of the Section 3 review. And this concludes the read of Section 3.